Assalamualaikum and hi to everyone. Thank you for watching this video. So in this video, we'll discuss about the connecting devices. So connecting devices can be divided into 5 different categories based on the layers in which they operate in the network. And why we need the connecting devices? The connecting devices is needed in order to help us to create a network. So this device help us to connect stations or nodes or any other devices and work as the network. Instead of connecting a network, instead of connecting the devices, it also do help in order to connect between LAN to another LAN. So the devices is based on the network. We can categorize based on the network. So the first part, you can look at the layers, 5 layers: physical, data link, network, transport, and application. So the first, we have those which operate below the physical layer, such as the passive hub. The second category is those which operate at the physical layers. Example here, we have the repeater or an active hub. The next one is those devices that operate at the physical and data link layers, which refer to the bridge or 2-layer switch. Okay, the fourth category is those devices that operate at the physical, data link, and network layers, such as a router or 3-layer switch. And the fifth category, those which can operate at all 5 layers, such as a gateway. So these are the 5 categories of connecting devices. Okay, the first part, we can go for the passive hub. So a passive hub is a connector. It's just a connector that allows several devices that connect together. So it is part of the media, and its location is the internet model is below the physical layers. Okay, you can refer back into the layers in the internet model, so below the physical layers. Okay, the next one is a repeater. So a repeater is a device that operates only in the physical layers. A repeater connects segments of a same LAN. Signal that carry information within a network can travel a fixed distance before attenuation endangers the integrity of the data. So this repeater receives that signal, and before it's become too weak or corrupted, it will regenerate the original bits pattern and forward to the next part. Okay, or then it send the refresh signal. So a repeater can extend the physical length of a LAN. Okay, for example, this video, so it's connected by devices. We have segment 1, segment 2, and then connected using the repeater. So when the signal from this computer travel to this computer, at this side, it will refresh or regenerate the original bit pattern of the signal. Okay, a repeater forwards every frame and it has no filtering capability. So the main part of the repeater, you need to remember that it just forward all the frame that it receive without any filtering capability. So a repeater is a regenerator, regenerates the original bit pattern. It is not an amplifier. Amplifier try to amplify the signal, but repeater just regenerate the original bit pattern. That is the difference between the repeater and the amplifier. Okay, you can refer to figure A, right to left transmission. So this is the corrupt signal when they travel through the network. So when it meets the repeater, so the repeater will regenerate the bit pattern to the original pattern. Okay, both show how the repeater works when it receives the signal of data. An active hub is actually a multi-port repeater. So it used to create connection in a star topology. If you still remember the topology, star topology, okay, it has hub at the middle of the topology. So also be used to create multiple level of the hierarchy. So this one, active hub at the middle of the topology, star topology. Okay, the next part is the bridge. So bridge operate in both physical layers as well as at the data link layers. So at the physical layers, it regenerates signal, and at the data link layer, it can check the MAC addresses content in the frame that travel through the network. So a bridge has a table used in filtering decision. So we call it bridge table. So the bridge can decide if the frame should be forwarded or dropped. Okay, this example, how two LAN is connected using the bridge. So this one we call as the bridge table. Inside the bridge table, it has the MAC address of devices that connected together. So a bridge does not change the physical MAC address in the frame. It just store the data. Okay, bridge connecting different LAN or different network. So theoretically, a bridge should be able to connect LAN using different protocol. However, there are many issues to be considered if we have different protocol. So the first part is the format of a frame that travel through the network. Each LAN type has its own frame format. So that can be issue that we need to consider if we want to use the bridge in order to connect both multiple network, multiple LAN. Second is the maximum data size. So the bridge will discard any frame that too large for its system. So we must make sure that the maximum data size can be handled by that bridge. Number 3, the data rate. The bridge must buffer the frame to compensate for this difference. Number 4, bit order. So each LAN has its own strategy in sending the bits. So we need to consider how the arrangement of the bits in a frame. Okay, number 5, the security. Bridge receive a frame from a wireless LAN must decrypt the message first before we can forward to the Ethernet LAN. Okay, wireless LAN without wire, Ethernet LAN with the wired. And multimedia support. Not all the LAN supports multimedia services. So we need to consider if we want to use the bridge in order to connect multiple network. So a 2-layer switch is a bridge with many ports that allow better and faster performance. It has a buffer to hold the frames for processing. I mean, it has the waiting time before it can process. Okay, a router route packet based on their logical addresses. Bridge, we have the MAC address. In router, we have the logical addresses. So it has routing table that used for making decision about the route, which path need to be used. Table are normally dynamic. In bridge, we have the bridge table. It's just for storing the MAC address. For the router, it has the routing table. So based on the routing table, it helps in order to make a decision, in order to choose which route to arrive, which route to be used in order to send the packet. So this show you on how routers connecting independent LAN and WAN. So we have LAN and LAN here. So this LAN and these LANs are connected through the WAN. So we need to use the routing or routing table. We need to use the router. So this is symbol of the router in a network. Okay, the next, a 3-layer switch is a router, but a faster and more sophisticated. So when we talk about the 3-layer switch, it also a type of kind of router, but it is more sophisticated compared to the router. Okay, the next one is a gateway. So the gateway operate in all 5 layers of the internet model, or 7 layers in the OSI model. It take an application message, read it, and interpret it. We use the gateway as a connecting device between 2 internetworks that use different model. So connecting networks. So the next part is the backbone network. So backbone network is based on topology that we have learned before. So using the backbone network allow you to have several LAN to be connected, and in a backbone network, no station is directly connected to the backbone. The station are part of the LAN, and the backbone connect the LAN. So let's say we have 3 LANs, so we connect all the 3 LAN using the backbone of the network. So basically we have the bus backbone, star backbone, and connecting remotely. Okay, so in a bus backbone, the topology of this backbone is a bus connect single or multiple flow building on a campus. The example of the bus backbone or bus topology is our campus. So we use we have multiple floor level in one building. So we use this kind of backbone in order to connect all the LAN together. Okay, so this is your backbone of the bus, and we use the bridge in order to connect to the LAN. So it looks like the bus topology. And the next part is the star backbone. The topology of the backbone is a star. It looks like a star. So the backbone is just one switch, sometimes called a collapse or switch backbone. So it works like this one. We have switch here, and this switch connect multiple LAN together. So this one we call as the backbone switch for the star backbone. So other backbone network connecting remote LAN. So this one useful when a company has several offices with LANs and needs to connect them through the bridge. So this one is LAN 1, LAN 2, LAN 3. So connecting together using the bridge. So the connecting using point to point, because one LAN to another LAN, one LAN to another LAN. So we call this connecting remote LAN. So a point-to-point link acts as a LAN in a remote backbone connected by remote bridge. And the next LAN is the visual LAN. So we can roughly define a visual local area network as a local area network that configured using a software. So a switch connecting 3 LAN. This one is a switch. This one is one LAN, and another LAN. So we have 3 group of network connecting using the switch. So VLAN technology divides a LAN into logical instead of the physical segment. Each group membership in the VLAN is a work group in the organization, and this is defined by a software or application. So we use the software in order to group certain PC into a several LAN. So the benefit using the LAN, we can easily remove and add without physically go and configure to that location. Okay, this one is another part. We have switched with the VLAN software, and we have VLAN 1, VLAN 2, VLAN 3. So easy for us to assign or configure this PC belong to VLAN 1, and easy for us to change this PC to another VLAN 2 or VLAN 3 because the process is using the software remotely. Okay, this example using the VLAN, which is the backbone switch. So we have two backbone switch here, switch A and switch B. So we can change remotely. So VLAN create broadcast domain, and VLAN group station belonging to one or more physical LAN into broadcast domain. So how you can group together the station using the LAN. So characteristic used to group station in VLAN is based on the port number, the MAC addresses, IP addresses, multicast IP addresses, and the combination. So these are the characteristics that we can use in order to group a station in the visual LAN. The port number, MAC addresses, IP addresses, and multicast IP addresses. And we can combine either two of them or three of them in order to create a characteristic as a VLAN or visual LAN. So advantages of the visual LAN. First is the cost and time reduction. We can reduce the cost and we can reduce the time of the configuration. So reduce the migration cost physically from one place to another place. And we also can reduce the time of station going from one group to another group. Without the visual LAN, we need to go to that station, to that device or PC, and then move it physically. Using the VLAN, we can just do the process of grouping remotely using the software. The second advantage, we can create a visual work group. So people or station in the same visual group can send a message and do interaction and communication. So can send a broadcast message to one another in different department or building. Number 3 is the security. User in other group will not receive their messages. So it's more secure if we can use the VLAN because we can configure the process of sending and receiving message. So based on this chapter, we have discussed the internet technologies, the evolution of the internet, and then under the internet part, you should know about the MAC and the physical sublayers, physical sublayer, and the physical implementation, type of cable, type of topology for each internet, standard internet, fast internet, giga internet, and 10 gigabit internet. Under the wireless internet, you should know the architecture and the station type, ESS, BSS, okay, MAC sublayer, and the frame format. Under the Bluetooth, you should know the architecture, Scatternet, Piconet, and the layers under the Bluetooth and how they communicate using the hop to hop, single secondary station, multiple secondary station. You should know that part. And then under the connecting devices, okay, there are several devices we have hub, we have repeater, hub, we have passive, we have active, and then we have the repeater, we have the switch, 2-layer, 3-layer, and then we have the bridge, and also the concept of visual LAN. So that's all, and hopefully you're able to understand the process of communication using the Ethernet, communication using the wireless, Bluetooth, what kind of the devices that we can use in order to connect several devices together to make a LAN, and how we can connect multiple LAN together using the connecting devices, and also the concept of visual LAN in the network. So that's all. Thank you and Assalamualaikum.